Okay, I think we could start our next presentation. Kirill and Vasily will speak about MongoDB shared versus PostgreSQL Citus. We represent in-country company. It provides the service of secure data storage in the country that the customer selected. This security is provided by certificates ASOC, BC1SS, and HIPAA, and they are represented in 62 countries, so the customer can make a choice. My name is Aleksandr Spirin. I will say a few words about the architecture of databases and tests. After that, Kirill Kalistratov will tell you about the architecture of tests and summarize the results. And because of the format, Vasily Soshnikov cannot present, but he is here in the room and he can answer the question. But I think that we won't have any time for questions, so they can be discussed behind the scene. Who of you has used MongoDB? That's great. And tell me, please, who of you has used Citus? Thank you. So here we have experienced people. That's why I will not speak about the architecture of DBMS a lot. I will describe the tests themselves. So the central issue is, what did we want? Did we want to compare the technologies, the databases? What was our final goal? We had a specific business task. So we had ready architecture and we were to select the machines. I mean, not even select the machines, but compare the machines. The system where we conducted these tests was devised for operation on physical machines, not virtual ones. And it was devised for large volume of data, millions, dozens of millions documents. But we made our tests on virtual machines. Disk space was quite limited, so we used units of millions documents. After that, it was supposed that we would scale up the results we received and compare them somehow. So we will not say that Postgres is better or worse than MongoDB. We will just show you what we did, we will show you the results, and you will make conclusions by yourself. On this slide, you can see the minimum deployment of Mongo cluster. Here you can see two charts on the bottom. On the top you can see the replica for the servers. You can see longer rotor and longer S on top of it, and I will not actually stop here. The important thing is that minimum deployment will cost you 9 servers, and in Postgres world that is a bit too much. This is the architecture of solution on the basis of Citus. On top of it, you can see the layer of application, synchronous replication, under the guidance of Patroni, works between routers. We actually compared Community Edition of Mongo and Citus. You know that Citus was acquired by Microsoft company. And Community Edition of Citus has one fundamental limitation. In the Community Edition, only one router is available, while in Mongo, indefinite number of routers is available. This is a single fault point, so we tried to overcome it through synchronous replication with manual switch if it fails. I'd like to emphasize that our goal was to get the results of the solution's performance and features of their use, including the cost of the solution, but we had no tests regarding the things that would happen if a machine fails. We didn't have such tests, we didn't do such tests. The bottom part of the slide is devoted to Citus cluster on 6 machines. This was the central challenge because we wanted Citus and Mongo to have similar chances. So Mongo had 6 data servers. It means that Postgres had to have 6 servers as well. How can we deploy a cluster on 6 servers? In among the architectures we considered, we decided to select the following one. All 6 machines are workers. We did not find an opportunity to regulate the storage of data copy. There is the notion of replication factor that actually defines the amount of data copies that are stored in the cluster. And if there are 6 machines, if we take replication factor equal to 2 or 3, it can turn out that all the data copies are located in one data center. And in that case, if it fails, we will have no data copy. In that case, replication factor was selected as 4. 4 is more than 6 divided by 2. So the copies were maintained due to Postgres logical replication. And I'd like to emphasize special features of Community Edition of both solutions. Both Citus and Longe had static sharding. I mean that the sharding key cannot be changed in a simple manner. In Longe, Community Edition is quite similar to Enterprise Edition. I mean that its engine is quite similar. The difference is something that surrounds the engine, monitoring properties, backup properties, these kind of issues. And Citus has the problem of unified router, and the problem is that we cannot add a new computer into the Community Edition in a simple manner. Both systems have their own properties that influence their use. I'd like to remind you that this was one of the goals of the study, to understand how much the usage of this system would cost. In MongoDB better, a good process is balancer. So due to this process, you can fail to calculate something during several hours. Mongo actually builds indexes for a very long time. This test was done on the latest versions, Postgres 12, Longo 4.2, Citus 9. And the indices are built during a very long time, and after you loaded the data and start building indices, it takes you several hours to receive the indices, and after that the balancer works takes several more hours. This was a surprise for us. The top part actually represents the data. The data are stored in one table. The top part of the table includes fields, their types, that we received from the architects, and we were not able to influence them. The first fields were ID, filter from 1 to 5. These are the fields on which we can conduct the search that will be indexed. And also here we have a field with data. I'd like to emphasize that we have only encrypted data in this table. Everything below document edition, created, updated, these fields are not significant for the essence of this issue. So the key fields, such as string 128 to 256, how will we index them? Building B3 index on such fields is quite difficult. That's why we decided to use hash index, and it was a surprise for us. It turned out to be 6 times smaller. It works much faster. But there's always a flaw in the ointment. Hash index cannot be compound. It is useful when we make comparison for equations, and it is not useful when we search by a range. A property was that when we select something from the list and one hash index cannot cover the whole query, another index is present in the query, then Postgres overlaps 2 indexes, and it is not as good as it could be. So, part of the indices were built as hash, and part of them were B3. Now I'd like to give the floor to my colleague. Thank you, Sasha. So, I can say a few words about testing. I'd like to mention, first of all, what we have. We have Mongo hardware. That is quite clear. 2 servers for routing, C5, 2 config servers, 3 config service, and 6 DVD. For Mongo, that is a bit less expensive, 2 of them for the app and 6 of them for the database, because we wanted to have similar conditions. And what are the requirements for tests? We have various sizes of documents for document field, that is 2, 4, 8, 16 kilobyte, and we have a variable size that is the business case actually.
So the number of documents was selected in such a way that the size of the database and the memory would be 2.6, so that the query would fit into the disk. In Mongo, we did not use this option not to read the secondary nodes. Those were the conditions. What could we change in the test? We can change different indices, hash, bit3, as Sasha said. We can change the data storage mode with compression or without compression. This is the basic scheme. If we change the storage mode, it will cause other changes. Let's discuss the test architecture, which is quite simple. Who used gmeter? Excellent. Tests can be launched through Jenkins or through plugin Slacker. What do we need for tests? We need to be able to support them, the required number of RPS, good maintenance, apply different load profiles. For that, we use Taurus as a wrapper, which is executed at gmeter servers. In Dockers, test data is taken from Redis, random data, and strings are made of those data, telemetry in Influx, and also it is possible to read from a separate shard. The script is simple. As I said, we use JDBC drivers, statement, query, and connection, search, reading, transaction, all separate, to understand what we spend time on. So we form the load profile. For Mongo and Postgres, it will be the same percentage-wise across the queries. But in terms of selects, there will be different options. We have inserts, deletes, and updates, various filters. I won't show you the Mongo slide, but it will be available for you in the presentation. Well, actually, it is in the presentation. You will see how Mongo query looks like. This is what our script looks like. It is longer, but this is only a fragment for your familiarization. Max capacity scenarios, step-like loads with time for stabilization of the system. This is standard. Outcomes. We have selected the most interesting tests. First, we have tests 2, 4, 8, 16 kilobytes with a storage mode by default. Then we changed the storage mode, where some fields are stored in the field and others in the test. 4 kilobytes of variables, variable size. And then we have all different types of documents, different sizes of documents, where we store data without compression. You need to understand that this time is the pop time at a minimal load. Of course, if the load is high, times will change. One column is the sum of all times of responses. The lower the column, the better. The shorter the time. This is on the search. These are outcomes for fetch, Postgres, followed by outcomes received at the best successful moment before the server shut down, the maximum achieved RPSs, disk latency. You can see that the bigger the document, the lower the latency. Options, IOPS, CPUs. Here you can see that the processor spends a lot of time interacting with the disk, because our servers are not so good, so to speak. Mongo outcomes. We had a lot of tests, and we have selected the 4 best ones. We have base scenarios. Well, the second scenario is where we deleted uniqueness and we tested manually. We searched for hash in tables. If we found it, we did not insert it. And 2 options for improving indices. When we compared Mongo and Postgres for indices. This is the same, the lower the column, the better. This is the aggregate time. This is MongoDB fetch. So you can see that the columns are high. Mongo just stumbled over the disk. These are the maximum achieved RPS. CPU, you can see that it spends a lot on the disk. All the time is spent on the disk interaction. So these are the main slides, comparisons. Here we compare Mongo and Postgres for search and find. You can see that Mongo is slightly faster because it spends a lot of time on fetch. So you can see how much it spends on fetch, and it will be even more visible on the following slides. Here, Postgres stumbles over the disk, but not as much as Mongo. This is the maximum achieved RPS before everything gets bad. The number of bytes sent, disk latency. Interesting. So the maximum is 10 seconds, and for Postgres it is 1. For Mongo it is 10, for Postgres 1. These are the IOPS. Summary. So both products are good in their own way. There are special features. Postgres is more predictable and requires fewer infrastructure servers. But the minimal deployment of Mongo requires 9 servers, and this is expensive. For Postgres, it is hard to have horizontal scaling, and there is no appropriate product for that. That's all I have. Thank you, and questions. I have one question, if I may. Did you compare Citus, which was not an enterprise version, a community version? Yes, it was a community version. As I understand, it is commercial, and it is not based on the latest version of Postgres. If you could compare with vanilla version, Postgres 12, for instance, could we expect better outcomes? Citus has an extension. For Postgres server, we used a vanilla version, Postgres 12. So we used the recent versions of all products, so including Postgres. And also the database service worked in the compiling mode. I wish we could have shown you twice as many slides. So actually we do have twice as many slides as we have shown. So they contained a lot of important information. So you will be able to read the comments and to see those slides when the steering committee uploads the presentation. Yeah, 22 minutes is not enough to cover such a subject. Indeed. The comparison slide raises a lot of questions. Postgres and Citus achieved 1,000. Is it good or bad? Is it a lot or not for Mongo? Mongo can improve this outcome 6 times because it can read concurrently. So if you can install 6 Mongo S routers, so the performance will be 6 times better. And Citus does not have this opportunity. So for Mongo, as I said, we can improve the performance 6 times, but not for Citus. That's why there is a big question, which product demonstrated better performance? I think it's a question to our managers, to our senior leadership. Let me add, it's an important comment. Yes, conditions should be the same. If we read replica, then the traffic would increase on all servers. And yes, then the systems would not be identical, and we would not be able to compare. There is one question from our foreign colleague, if you allow.
Did you experience with the Did you experience with the rebalancing when you add a new shard in Citus?
No. Коллега спрашивает, да, имели ли...
Yes, did you have an experience of adding a new shard in the Citus? No, we haven't done this, no. What we did was only routine transactions with respect to the stable status of a cluster. So the answer is no. And we did not test fail safety or the speed of switching. And as I noticed in the slides, there are restrictions for adding new shards. In Enterprise Edition, you can add shards dynamically. In Citus, no. So do you mean to say that some downtime will be necessary or a server offline? I think you need to talk to the marketing service of Microsoft. They will respond to that question. Thank you.